Have you ever imagined a bear so colossal that it could rival a dinosaur? Get ready to discover Arctotherium, a prehistoric predator whose enormity is breathtaking and rivals the fearsome Allosaurus. In this video, we will learn how this Pleistocene giant dominated its territory and uncover the secrets of its impressive adaptation. If you are fascinated by creatures that seem to have come out of an epic, connect with the grandeur of nature, and want to know how a bear can be as immense as a dinosaur, you will not want to miss this journey. Let's discover together how Arctotherium stood out in the fierce competition of its time and how this story can change your view of prehistoric life. Press play and embark on this adventure with us. First, I would just like you to check if you are already subscribed to the channel. I would be very happy to have you with me on this journey. Origin and discovery of Arctotherium. The discovery of Arctotherium fossils in Argentina. The discovery of Arctotherium fossils occurred in the mid-20th century, when paleontologists were exploring the vast fossil regions of Argentina. The first significant identification of this giant bear was made in the province of Buenos Aires, in a location known for housing a rich Pleistocene fauna. Researchers found fragments of bones and teeth that were initially difficult to identify due to their unusual size. Over time, these fragments were recognized as belonging to a new genus of short-faced bear, leading to the name Arctotherium, which means northern bear. Geological conditions and the significance of the discovery. The region where the Arctotherium fossils were found is known for its geological formations of the Pleistocene, a period that runs from about 2.6 million to 11,700 years ago. During this time, South America experienced several climatic and environmental changes, which influenced the local fauna. The sediment layers where the fossils were discovered suggest that Arctotherium lived in a varied environment, consisting of plains, forests, and marshy areas. The discovery of these fossils is of extreme importance because it provides valuable information about the diversity of giant mammals in South America during the Pleistocene, a continent that was home to an impressive variety of megafauna. In addition, detailed study of the fossils revealed unique anatomical features in Arctotherium, such as its deep skull and powerful jaws, adapted for a diverse diet that included both meat and vegetables. These discoveries not only expand our knowledge about the diet and behavior of these giant bears, but also about how they competed and coexisted with other large predators and herbivores of the time, such as smilodon and giant ungulate mammals. Impact on understanding giant mammals. The discovery of Arctotherium and subsequent research into its biology and ecology revolutionized our understanding of the giant mammals of South America. Prior to this discovery, knowledge about short-faced bears was limited and focused primarily on species found in North America, such as Arctodus. The existence of Arctotherium, with its diverse species that varied in size and morphology, showed that South America was also home to a distinct and successful lineage of large bears. This discovery also raised new questions about the evolution and extinction of these mammals. The study of Arctotherium revealed how these bears adapted to environmental changes and competitive pressures in their habitat. Furthermore, the fossils of Arctotherium angustidens, one of the largest known species, challenged preconceived notions about the size limits for carnivorous and omnivorous land mammals. Isotope analysis and tooth-wear studies suggest that these bears had a varied diet, which may have been a key factor in their ability to adapt to different ecological conditions. In summary, the discovery of Arctotherium not only expanded scientific knowledge about the Pleistocene megafauna of South America, but also highlighted the complexity and diversity of mammals that inhabited the continent. These discoveries continue to inspire new research and debate about the paleobiology, evolution, and eventual extinction of these fascinating giants of the past. Size comparison. Arctotherium versus Allosaurus. Dinosaurs have always fascinated humanity, largely due to their impressive size. Among the prehistoric giants, Allosaurus stands out as one of the most iconic predators of the Jurassic period. With sharp teeth and a muscular body, Allosaurus was a formidable hunter, measuring approximately 9 to 12 meters in length and weighing up to 2.5 tons. Its robust structure and powerful jaw made it a fearsome figure in its ecosystem. The image of such a colossal dinosaur is something that captures the imagination of many, representing a time when enormous creatures dominated the earth. Although Allosaurus lived millions of years before large mammals, Arctotherium, a prehistoric bear that inhabited South America during the Pleistocene, emerges as a comparably impressive creature. Arctotherium angustidens, one of the best-known species, is surprising not only for its existence, but also for its colossal size. It is estimated that some individuals of Arctotherium angustidens could have reached a weight of up to 2.4 tons, rivaling the weight of the largest Allosaurus. Furthermore, when standing on their hind legs, these bears could reach impressive heights, possibly exceeding 3.5 meters. The comparison between Arctotherium and Allosaurus is not limited to weight alone, but also extends to their physical adaptations and lifestyles. Allosaurus, being a carnivorous dinosaur, had a lighter skeletal structure, optimized for speed and agility, essential characteristics for hunting large sauropods and other herbivores. In contrast, Arctotherium had a more robust build and powerful muscles, adapted for a combination of hunting and digging, as well as an omnivorous diet that included both meat and vegetation. Arctotherium's strong jaws and sharp teeth were ideal for crushing bones, while its large claws helped it capture prey or dig burrows. A surprising closeness in size between the two. The surprising closeness in size between Arctotherium and Allosaurus defies expectations and highlights the astonishing diversity of life on Earth across different eras. While dinosaurs are often seen as the largest predators of all time, Arctotherium shows that mammals also reached immense sizes and played critical roles in their ecosystems. This closeness in size is even more remarkable considering the different geological eras in which they lived. Allosaurus in the late Jurassic, approximately 150 million years ago, and Arctotherium in the Pleistocene, approximately 1 million years ago. Comparing these two creatures highlights not only the continuous evolution and adaptation of predators over time, but also the incredible ability of mammals to fill ecological niches left vacant by dinosaurs after their extinction. The existence of a bear as large as Arctotherium reminds us that the history of life on Earth is filled with extraordinary creatures, each adapted in unique ways to survive and thrive in their respective environments. This closeness in size between a prehistoric bear and one of the most fearsome predatory dinosaurs underscores the fascinating continuity and transformation of life throughout the geological eras. Life in the Pleistocene period. The Pleistocene period, which lasted from approximately 2.6 million to 11,700 years ago, was an era of intense climate change and remarkable megafauna. This period is best known for its ice ages, which alternated with warmer interglacial periods, creating a dynamic and challenging environment for life on Earth. The Pleistocene fauna included a vast array of large mammals, known as megafauna, that evolved to adapt to the extreme conditions of the period. These animals included mammoths, mastodons, giant sloths, and the iconic saber-toothed tiger, smilodon, which dominated the landscape. South America, where Arctotherium lived, was home to a rich diversity of species, including camelids, glyptodons, and toxodonts, as well as several large predators. The Pleistocene South American ecosystem, particularly in the regions where Arctotherium has been found, was characterized by a variety of habitats, from dense forests to open plains. The forests provided shelter and a variety of food resources, while the plains were dominated by large grazing herbivores. These open areas were also the scene of epic hunts, where predators such as smilodon and the ancestors of the jaguar competed with Arctotherium for prey. The climate varied from subtropical to temperate, with some regions experiencing dry periods and others being more humid, creating a diverse landscape that required specific adaptations from the animals that lived there. Arctotherium, as one of the largest carnivorous mammals of its time, occupied an important ecological niche as an apex predator. It coexisted with other notable species such as the fearsome, a huge predatory bird, and Xenarthra, such as the aforementioned glyptodonts and giant sloths. This environment was a complex web of predator-prey interactions, with intense competition for food resources. In addition, Arctotherium would have faced survival challenges due to climate change, which affected food availability and prey migration patterns. How Arctotherium adapted to its environment to survive in this challenging environment. Arctotherium developed several remarkable adaptations. Its large body mass and robust build were ideal for subduing a wide range of prey, from small animals to large herbivores. The powerful jaws and robust teeth indicate a diverse diet that included both meat and vegetation, showing that Arctotherium was an opportunistic omnivore. This dietary flexibility would have been crucial in times of prey scarcity, allowing the bear to exploit a variety of food sources, from roots and fruits to active hunting and scavenging. In addition to its adaptable diet, Arctotherium also displayed physical adaptations that made it an efficient predator. Its long legs and powerful claws not only made it easier to catch prey, but also allowed it to dig for roots or compete with other predators for carcasses. The skeletal structure of Arctotherium, with its broad skull and strong bones, suggests that it could withstand considerable force when fighting or defending territories. Another crucial adaptation was its potential for social behavior, which may have included living in family groups for mutual protection and cooperating in hunting or defending prey. This socialization may also have been a response to harsh environmental conditions, allowing individuals to share information about feeding and sheltering locations. The combination of these adaptations allowed Arctotherium to thrive in a period marked by great climatic variability and fierce competition. However, like many other megafauna species, Arctotherium eventually faced extinction, probably due to a combination of climate change and increasing human pressures. The legacy of Arctotherium, however, lives on in its fossils and in the lessons that these ancient giants have to teach us about adaptation and survival in an ever-changing world. The physical characteristics of Arctotherium. General physical characteristics of bears, as a family of mammals, are known for their robust build, impressive strength, and adaptability to a wide range of environments. Bears generally have massive bodies, dense coats, broad skulls, and powerful jaws. Their sharp, strong claws are used for digging, hunting, and in some cases climbing trees. These physical characteristics are adapted for a varied diet that can include meat, vegetation, fruits, and in some cases insects. The ability of many bears to hibernate is also a significant adaptation that allows them to survive in environments where food resources are scarce during the winter months. Arctotherium, one of the largest bears that ever lived, had several unique physical characteristics that distinguished it from its modern relatives. One of the most notable characteristics was its deep, broad skull, which provided a large surface area for the attachment of powerful jaw muscles. This robust skull, along with large canine teeth and molars adapted for grinding, indicated an impressive ability to chew and process a variety of foods, from tough, fibrous meat to vegetation. Furthermore, Arctotherium had long, muscular legs, which gave it a more upright posture and a greater reach than other bears. These long legs not only increased its ability to travel great distances in search of food, but also gave it an advantage in encounters with other large predators or competitors for carcasses. Its claws, while powerful and capable of delivering lethal blows, were also useful for digging, both in search of roots and tubers and for creating burrows or accessing the carcasses of large animals. Another interesting aspect of Arctotherium was its extreme body mass. Weighing up to over 2,000 kilograms by some estimates, Arctotherium was a true giant. This enormous mass not only made it one of the most formidable predators in its ecosystem, but also helped it to maintain heat in colder climates, a crucial adaptation during the glacial periods of the Pleistocene. Arctotherium's impressive size also meant that it had fewer natural predators, allowing it to dominate the top of the food chain. How these traits aided survival and hunting. Arctotherium's physical characteristics played a crucial role in its survival and success as one of the top predators of its time. Its robust skull and powerful jaw allowed it to break down bones and access the nutrient-rich marrow, a significant advantage when it came to fully utilizing the carcasses of large herbivores. This also put it in an advantageous position as a scavenger, effectively competing with other large predators and scavengers. Arctotherium's long, muscular legs not only facilitated movement across varied terrain, but also allowed it to reach great speeds over short distances, making it an effective hunter. This ability for speed, combined with its strength and powerful claws, made it capable of taking down large prey such as toxodonts and glyptodons that coexisted in the same habitat. Furthermore, the ability to burrow also allowed it to create burrows, both to protect itself from the elements and to create shelter for its young, if it was a social animal. The enormous body mass of Arctotherium was an adaptation not only to intimidate competitors and predators, but also to store energy in the form of fat, crucial for periods of food scarcity or harsh winters. This fat also provided insulation against the cold, allowing Arctotherium to survive in regions that experienced significant climatic fluctuations. In short, the physical characteristics of Arctotherium were adapted in such a way as to maximize its chances of survival in a competitive and challenging environment. These adaptations allowed it to be both an efficient predator and an opportunistic scavenger, securing its position as one of the largest and most formidable carnivorous mammals of the Pleistocene era. Diet and feeding behavior of Arctotherium. Feeding habits of large predators, whether extinct or extinct, play crucial roles in their ecosystems, often occupying the top of the food chain. These animals, due to their size and power, are generally specialized in hunting large prey, but they can also be opportunistic scavengers. The feeding habits of these predators are diverse and depend on a number of factors, such as prey availability, competition with other species, and environmental conditions. In many cases, the diet can include a variety of foods, from meat to vegetation, depending on need and circumstances. This flexibility in diet can be a key to survival, especially in constantly changing environments. Including meat and plants, Arctotherium, one of the largest bears that ever lived, had a varied diet that reflected its omnivorous nature. Based on fossil analyses and studies of tooth wear, scientists suggest that Arctotherium consumed a wide range of foods. Meat was certainly an important part of its diet, with prey likely including large Pleistocene herbivores such as toxodons, giant sloths, and glyptodons. The ability to hunt and bring down these large animals was facilitated by its impressive strength and sharp claws, as well as its powerful jaws that could break through bones to access the nutritious marrow. In addition to hunting, Arctotherium would also have fed as a scavenger, taking advantage of carcasses left behind by other predators or natural deaths. This not only increased the amount of meat available for consumption, but also reduced the energy required to obtain food. This ability to switch between hunting and scavenging would have been particularly advantageous during periods of scarcity of live prey. Furthermore, evidence suggests that Arctotherium was not exclusively carnivorous. Its diet also included a variety of plant material. This is indicated by the shape and wear of its molar teeth, which are adapted to grind not only meat but also fibrous plants. Fruits, roots, tubers, and even leaves could have been part of its diet, especially at times when hunting was less fruitful. This omnivorous diet indicated an ability to adapt to different environments and food availability, essential for survival in diverse ecosystems. How its varied diet contributed to its survival. Arctotherium's varied diet was one of the keys to its survival during the Pleistocene. By being able to consume a wide range of foods, from meat to vegetation, Arctotherium did not rely exclusively on a single food source. This flexibility allowed it to adapt to changes in prey populations and environmental conditions. For example, during periods of climate change that affected the availability of large herbivores, Arctotherium's ability to consume plants could have been crucial to its survival. In addition, Arctotherium's omnivorous diet allowed it to exploit different ecological niches. It could compete with other large predators for prey, but it also had the ability to feed on plants and fruits, reducing direct competition. This nutritional versatility not only broadened its dietary spectrum, but also made it less vulnerable to fluctuations in prey availability. In summary, Arctotherium's diverse diet was a vital element of its ecology, allowing it to survive in a challenging Pleistocene environment. Its ability to switch between carnivorous and herbivorous feeding habits placed it in a unique position to exploit diverse resources and ensure its subsistence across different ecological settings. This dietary adaptability may have been one of the reasons why Arctotherium was able to thrive for such an extended period before its eventual. The role of Arctotherium in the ecosystem. Concept of ecological niche. The concept of ecological niche is fundamental to understanding how different species coexist and interact in an ecosystem. An ecological niche is defined not only by the physical space that a species occupies, but also by the role it plays in the food web and ecosystem dynamics. It encompasses all the environmental factors that the species needs to survive, such as food, shelter, and climatic conditions, as well as its interactions with other species, whether predatory, competitive, or symbiotic. In essence, The ecological niche is the address and job of a species within the ecosystem, and each organism has a unique role that contributes to the stability and functionality of the natural environment. Arctotherium's role as a predator and scavenger. Arctotherium, one of the largest bears ever to have lived, played a crucial role in the Pleistocene ecosystem as an apex predator and scavenger. As a predator, Arctotherium hunted a wide range of large herbivores that inhabited South America at the time, such as toxodons, giant sloths, and glyptodons. Its impressive physical structure, with a robust skull, powerful jaws, and sharp claws, made it a formidable hunter, capable of taking down large prey. These characteristics allowed Arctotherium to control herbivore populations, maintaining a balance in the ecosystem and preventing overpopulation, which could lead to overgrazing and habitat degradation. In addition to its role as a predator, Arctotherium also acted as a scavenger, taking advantage of carcasses left behind by other predators or resulting from natural deaths. This scavenging behavior is a vital survival strategy for many carnivores, as it allows them access to a food source without the energy expenditure involved in hunting. For Arctotherium, the ability to feed on carrion meant that it could survive in times of scarcity of live prey, helping to sustain its large body mass. Furthermore, by consuming carcasses, Arctotherium played an important role in cleaning up the ecosystem, helping to prevent the spread of disease and recycling nutrients back into the soil. How its presence affected other species in the ecosystem. The presence of Arctotherium had a significant impact on other species in the Pleistocene ecosystem. As a top predator, it directly influenced the populations of large herbivores, controlling their numbers and consequently shaping the composition of local vegetation. The predatory pressure exerted by Arctotherium helped maintain plant diversity by preventing certain herbivore species from dominating and depleting specific resources. This, in turn, promoted a more balanced and resilient environment. In addition, as a scavenger, Arctotherium competed with other carnivores and scavengers for carcasses. This competition could have led to complex interactions with other predators, such as smilodon, the famous saber-toothed tiger, and marsupial felines, influencing their behavior and hunting patterns. The presence of a large scavenger like Arctotherium could also have forced other predators to adapt their feeding strategies or specialize in different niches to avoid direct competition. The importance of Arctotherium in the ecosystem was not limited to its influence on other animal species. Carcass removal also had beneficial effects on environmental health, reducing the presence of pathogens and promoting decomposition and nutrient recycling. Ultimately, Arctotherium played a vital role in maintaining ecological balance, influencing both the population dynamics of prey species and the overall health of the Pleistocene ecosystem. Its extinction, like that of many large mammals of the time, would have created a significant ecological gap, profoundly altering food webs and habitat structure. The extinction of Arctotherium. Causes and consequences. To large mammal extinction hypotheses. The extinction of large mammals, known as the Pleistocene extinction or the extinction of megafauna, is a complex and extensively studied topic by paleontologists. This event occurred at the end of the Pleistocene, about 10,000 years ago, and resulted in the extinction of a wide variety of gigantic animals that dominated the planet during the last ice age. Among those lost were iconic mammals such as mammoths, giant sloths, and Arctotherium itself. The extinction of these animals raises intriguing questions about the causes and factors that contributed to their loss. Several hypotheses have been proposed to explain this phenomenon, including drastic climate change, human impacts, and habitat alterations. Potential causes of Arctotherium's extinction. The extinction of Arctotherium can be attributed to a combination of factors that, together, created adverse conditions for its survival. Among the main potential causes are climate change. During the late Pleistocene, the global climate underwent significant changes. Global warming resulted in the melting of large ice sheets and the transformation of ecosystems. The forests and steppes that Arctotherium inhabited were replaced by new vegetative formations that were less suitable for its dietary needs. Habitat loss and reduced hunting areas may have reduced food availability and affected the survival of the giant bear. Predator pressure and competition. Diversification of predators and the arrival of new food competitors may have exacerbated competition for resources. The expansion of predators such as saber-toothed cats and large canids, in addition to the arrival of new species through the Great American Interchange, may have put pressure on Arctotherium, forcing it to compete for territory and food. Human impact, human activity including overhunting and environmental alteration, is also considered a hypothesis for the extinction of large mammals. The increasing presence of humans in the Americas may have led to the hunting of megafauna, such as Arctotherium, for food and other uses, further exacerbating the pressures on the population of these animals. Synergistic effects. The combination of these pressures may have created an unsustainable scenario for Arctotherium. The interaction between climate change, competition with new predators, and human pressures may have led to a gradual collapse of populations, resulting in the extinction of the giant bear. The extinction of Arctotherium had profound consequences for the Pleistocene ecosystem and the ecological dynamics of the Americas. As one of the largest terrestrial predators of the time, Arctotherium played an essential role in controlling the populations of large herbivores and maintaining ecological balance. Its extinction left a significant gap in the food chain, altering predator-prey interactions and affecting the structure and functionality of habitats. Without the top predator that Arctotherium represented, there was an increase in populations of smaller herbivores and a potential overload on plant resources. This could have led to changes in vegetation and habitat degradation, which in turn affected other animal and plant species. In addition, the loss of Arctotherium, along with other large extinct mammals, contributed to the alteration of biodiversity and ecosystem composition, promoting the rise of new species and adapting the environment to the climatic and ecological conditions that emerged after the end of the Pleistocene. The extinction of Arctotherium also had a cultural and scientific impact. The study of their fossils has provided valuable insights into the life and ecology of large mammals of the past, helping scientists better understand the conditions that led to the extinction of these giants. Furthermore, the disappearance of such species underscores the fragility of ecosystems and the importance of preserving biodiversity in maintaining the health and stability of natural environments. The importance of Arctotherium fossils for science. Paleontology is the science that studies life in the past on Earth through fossils, which are the preserved remains or impressions of ancient organisms. These remains provide a window into ecosystems of past eras and allow scientists to reconstruct the history of life, understand the evolution of species, and explore how environmental changes have influenced biota over time. The importance of fossils extends beyond simply documenting extinct life forms. They provide crucial data on ancient environments, behaviors, and ecological relationships between species. The Arctotherium fossils, discovered in Argentina, are particularly valuable to paleontology for several reasons. Exceptional preservation. The Arctotherium fossils were found in geological conditions that allowed for excellent preservation of the bones. The initial discovery of skull fragments, jaws, and long bones allowed scientists to reconstruct significant parts of the anatomy of this gigantic bear. The well-preserved fossils helped to accurately determine the size, structure, and physical characteristics of the animal. Insights into morphology. Studies of the Arctotherium fossils have revealed unique anatomical features, such as a deep skull and long legs, which are distinct from other bears and mammals of the time. These features have provided information about the animal's adaptation to its environment and its predatory and scavenging behavior. Habitat reconstruction. Analysis of the Arctotherium fossils, together with sediments and other remains found at the same site, has helped to reconstruct the habitat in which it lived. The presence of Arctotherium in different rock layers and in association with other fossils indicates the existence of a diverse ecosystem where large herbivores and other predators coexisted. Evolutionary study. Arctotherium fossils provide detailed insight into the evolution of bears and predatory mammals in general. Comparative analysis with other bears and predators from the same period allows scientists to understand how Arctotherium fit into the bear family tree and how its evolutionary characteristics compared with those of other large mammals. Arctotherium fossils have a significant impact on our understanding of mammalian evolution for several reasons. Evolution of bears. Arctotherium is a crucial example of the diversity and evolution of bears during the Pleistocene. Studying its morphology and adaptive traits provides insights into how bears evolved in response to environmental changes and ecological pressures. Size and adaptation. Arctotherium's immense stature and physical adaptations, such as its long legs and deep skull, help illustrate how mammals can adapt to specific ecological niches. These adaptations provide a clear example of how body size and shape can influence ecology and behavior. Ecological relationships. Analysis of Arctotherium fossils and the remains of its prey and competitors reveals the complex ecological interactions and predator-prey dynamics of the Pleistocene. Understanding these relationships helps to trace how environmental changes and competition between species shaped mammalian evolution and behavior. Extinction patterns. Studying Arctotherium fossils also contributes to our understanding of extinction patterns. By analyzing the conditions that led to the extinction of Arctotherium, scientists can infer the factors that influence the survival and extinction of other large mammal species, offering lessons about resilience and adaptation in the face of environmental change. Arctotherium fossils therefore not only enrich our knowledge of past life, but also provide a fundamental basis for the study of mammalian evolution and ecology, illuminating the complex interweaving of factors that shape the history of life on Earth. If you found it fascinating to discover how a bear could compete with dinosaurs in size and power, don't miss our upcoming videos. Subscribe to the channel to explore more incredible stories about extinct creatures, their lives, and the secrets they still hold. And if you have any questions or would like to see a specific topic in our videos, leave a comment below. Let's unravel the mysteries of the past together and understand how these giants of the earth shaped the world we know today.